The engineering robotic platform integrates sensor fusion algorithms with sophisticated state representations. In the context of sensor fusion, a state refers to aspects of reality to be estimated. The state consists of quantities needed as output for the robotic prototype, such as guidance and orientation. Additional quantities are needed in the algorithms in order to model the behavior of the robot by mathematical equations as shown in this video. Preparing for the next frontier when thought control machines, seamless brain-computer interfaces, using sensors to control Internet of Things devices, IoT, and artificial intelligence. Simply imagine intuitive movement to enable robotic systems and other industrial systems. The idea is to map the activity of the brain, knowing the brain consists of over 185 billion neurons. Technology is influencing the way we do things, and metaphysics of artificial intelligence is advancing significantly, projecting a new paradigm in developing new cognitive, machine learning, intelligent neuromorphic platforms. Artificial intelligence refers to a broad category of computing. System is able to learn directly from data. It is made possibly by the augment of data analytics and applied by the introduction of machine learning processes together with deep learning methodologies. This segment shows an actual prototype of the artificial intelligence platform for the autonomous robotic controller systems. The platform is scalable. This platform is integrated by sophisticated mathematical and artificial intelligence algorithms and software models. Intuitive thinking machines in robotics. The next stage of Industrial Revolution 4.0 is characterized by exploring and applying artificial intelligence through neuromorphic architectures in order to emulate the biological neurons and synapses of the cortex human brain. The objective of artificial intelligence research and development is to design thinking machines with human-like intelligence. The thought process is based on the assumption that different aspects of human intelligence can be described and it can be simulated mathematically with mathematical algorithms by cognitive representations and generic reasoning paradigms. Robotics, mathematical algorithms, and artificial intelligence. The development of non-standard systems of logic, including non-monotonic logic algorithmic control systems, and of algorithmic complexity theory, shows the process affecting cognitive science and mathematics. Mathematical algorithms used in this engineering prototype is an important tool used to study the dynamics and learning capabilities of feed-forward layered networks and distributed processes in cognitive systems. Human and robotic collaboration is common practice by intuitive of deep learning machines, transitioning to cognitive and convolutional neuromorphic artificial intelligence. The objective is to present several engineering prototypes in the field of artificial intelligence with applications in cybernetics and cyborg engineering. Cyborg engineering can have biological intelligence as well as artificial intelligence neuromorphic technologies. In this segment, I will introduce a general framework that shows the implementation of an artificial cognitive robotic hand and robotic glove. The objective is to design and develop kinematic algorithms for the control of sensory robotic systems. The kinematics is solved in the sensor coordinate. Thus, simplification of the algorithms is done when approximations are used to solve the inverse kinematics. The kinematic robotic is characterized by the use of algorithms of reading points of 3D space, floating interpolation by a polynomial of the fifth order, iterative process of solving inverse kinematics tasks, dynamic feed-forward torque of each motor, and calculation of position control algorithm with a control loop. The sensor is able to produce three components of the required linear velocity of the TCP in three orthogonal axes, and three components of the required rotational rates, such as angular velocity about this axis. The fast Fourier transform is a mapping of data between two domains using zero-based indexing. X of n represents the nth element of the input, and X of k represents the kth element of the output. X denotes the signal level at various points in time, and X denotes the signal level at various frequencies. The signal level at frequency k is equal to the sum of the signal level at each time n multiplied by a complex exponential. These FFT mathematical algorithms apply fast Fourier transform methods to the computation of convolution-like integrals that are endemic in robotic, kinematics, and motion planning. Fast Fourier transformation, FFTs, is a mathematical module that samples signals over a specified time segment. It measures every cycle that would include different variables of the system. FFT algorithms in robotics. Here I focus on the problem of computing the workspace density function for discretely actuated link revolute robotic. The robotic kinematic artificial intelligence generates the workspace density for the discretely actuated M-link planar revolute. Each link has one of n orientations relative to the previous link, and the length of each link, L of I, has a fixed value. The kinematic robotic arm generates the workspace density of a sixth link, such as vibrations from the surrounding and noise that is generated as the robot is at rest or in motion. This will disrupt the environmental and the system functioning network. Real operations requirement in FFTs. A complex addition can be implemented as two real additions. Generally, a complex multiplication can be implemented as three real multiplications plus five real additions. In the case of the fast Fourier transform FFT, use of efficient radix minus 2, radix minus 4, or radix minus 8 algorithms can be used to reduce the number of non-trivial operations required. Thus, the computation requirement to implement the FFT and the training algorithm is given by a computational requirement to implement the FFT and a decision-directed adaptation algorithm. The computational requirement of an FFT, first Fourier transform, is given by the equation NC_MUT minus FFT is equal to n log 2 n over 2. Secondly, the number of complex multiplications and additions must be translated into real operations. Finally, the MIPS required must be calculated from the number of real operations required and the relevant parameters for each of the standards under consideration. Multiplications of real or complex numbers are very demanding. The complexity requirement is evaluated in two ways. In one case, only the multiplications are considered. Fast Fourier transform mathematical models. A discrete Fourier transform can be computed using an FFT. 1. If the number of points n is a power of 2, or if the number of points n is not a power of 2. A transform can be performed on sets of points corresponding to the prime factors of n, which is slightly degraded in speed. The FFT algorithms fall into two classes: decimation in time and decimation in frequency. Neural geometric intuitive paradigm creates cognitive symbiosis between humans and thinking machines, fusing artificial intelligence with human intellect to enable humans to have a higher degree of cognitive intellectual output. Deep Science Engineering Platform has machine perception, allows the computer to use the sensory inputs as well as conventional computational means of gathering information. Computational neuroscience is a branch of neuroscience which employs mathematical models, theoretical analysis, and abstractions of the brain to understand the principles that govern the development, structure, and cognitive abilities of the nervous system. Convolutional neural networks are networks that use many identical copies of the same neuron. This allows the network to have lots of neurons and express computationally large models while keeping the number of actual parameters. For an artificial intelligence autonomous stochastic robotic system to accomplish tasks when the outcome of actions is non-deterministic, it is necessary to apply error correction and error detection. Neuromorphic architectures. The idea is to connect all neurons on the architecture just as it is done by the human brain. Therefore, we are simulating the function of the brain in silicon, driven by complex neuromorphic mathematical algorithms. Essentially, neuromorphic architectures generate electrical signals that act as stimuli to the neurons, axons, dendrites, and synapses, very similarly as how the human brain is able to reason in real life. Deep learning in artificial intelligence. Each level learns to transform its input data into a more abstract representation. For instance, in an image recognition application, the raw input may be a matrix of pixels. Software Kalman Quaternion filters, servo motor control algorithms. There are other programs embedded in this robotic application within the realm of artificial intelligence paradigm, that is machine learning, cognitive mathematical representations, and convolutional neural network software models. Smart glove and bionic hand illustrating software algorithms, firmware integration, and artificial intelligence. Bionic hand artificial intelligence. Electrode sensors are placed on two nerves, that is the ulnar and median nerves, located in the human arm. These nerves normally would allow for certain sensations in the hand. The idea is to electrically stimulate those nerves, thus transmitting the signal to the smart glove and the bionic hand fingers to enable it for dexterity. The bionic hand receives information from the brain via the ulnar and median nerve, thus providing sense of feel, touch sensitive, essentially creating a loop to let the bionic robotic hand to communicate with the brain. Motor software. Here is an illustration of the software models which activate the motor movement. The software is created with C++ and Python, integrating solutions for pulse width modulations by controlling several analog ports located on the main computer digital platform. Wi-Fi communications protocol. Data is sent over Wi-Fi to any IoT device, including a PC computer and/or an Android device. It also communicates with the bionic robotic hand in order to control neural movement of all bend sensors, and joints. Neural engineering technology. Artificial intelligence refers to a broad category of computing. System is able to learn directly from data. It is made possible by the augment of data analytics and applied by the introduction of machine learning processes together with deep learning methodologies. Deep learning applies to neural network. It is a subset of machine learning, integrating neural network techniques that enable systems to learn from large amounts of data